Okay, in this lesson, we are going to be looking at some double and half angle formulas as ways to solve some problems using the unit circle. So in this case, we are being asked to solve for x in this problem. I'm needing to find where cosine at 2x is equal to cosine at x somewhere between 0 and 2 pi, which basically means you're somewhere on the unit circle. Okay, so what you are going to do is you are going to replace this with one of the double angle formulas. This, by the way, is not the same as that. Just so you know, it doesn't mean that I can take cosine of x and multiply it by 2. It is not the same thing. I'm taking twice the angle, x in this case, so I need to use the double angle formulas. I want you to notice that you have 3 double angle formulas, and these are on your master formula sheets, by the way. You have 3 to choose from, and you can choose any of the 3. It really doesn't matter. However, what I want you to notice is that on the right side of this equation, we have cosine x. And so I am, just to simplify this, I am going to replace the double angle formula, the cosine 2x, with the formula that only has cosines in it. So I'm limited to one trig function. So I'm not going to choose this one because it has sine in it. I'm not going to choose this one because it has cosine in it. I will choose this one to replace that with, so that when I have cosine on this side, I only have cosines in my equation and I have one trig function. So I'm going to replace this cosine 2x that's circled with cosine 2 cosine squared x minus 1. And then I'm here. Okay? Now what I need to do is, this is kind of like a quadratic equation that has trig functions in it. So I am going to move this cosine to the other side so that it looks like this. Okay, and then you're going to think about factoring it. So I can factor this, and my fronts need to make my front. So remember, you're going to have 2 cosine times cosine, so that I get 2 cosine squared. My backs will need to be 1 times 1, which makes 1. If this is a negative right here, I need to have 1 positive and 1 negative. Hopefully you can figure out that that one needs to be negative and that one needs to be positive. Okay, and then you're going to set each part of these equal to 0. So I will have 2 cosine x plus 1 equals 0. Subtract 1 divided by 2. Hopefully you can figure out that cosine x will be negative 1/2. And then if I set the other one equal to 0, obviously cosine x equals 1. And at this point now, I need to go to my unit circle, and I need to figure out where these places are. I'm going to pull my unit circle in here, which I should have done before, but I didn't. Okay, we're going to go to our unit circle and figure this out. So, and I'm going to make this small. I know you have your own unit circle. So what I'm looking for here is 2 things, okay? In this left-hand equation, I'm needing to figure out where cosine is negative 1/2. Notice I don't have an inverse symbol in there or the word arc in front of there, so I am not limited to restricted intervals. I need every place on the unit circle where my cosine value is negative 1/2. I want you to remember that cosine is x over r, and so your r is 1 anywhere on the unit circle, so cosine is basically your x value. So I'm looking for the places where my x value is negative 1/2. That happens right here. My x value is negative 1/2. And it also happens right here, where my x value, or my cosine value, is negative 1/2. So that will be 2 pi over 3 and 4 pi over 3. Okay, and then on the right-hand side, I'm looking for where cosine, which again, cosine is x over r. Cosine is your x value. I'm looking for where my cosine value is 1, which that happens right here at that spot, which you can either call 0 or 2 pi. I think it wants your answers from exactly 0 to under 2 pi. I'm going to call that 0 degrees or 0 radians. If you called it 2 pi, I might not come wrong, but they do want your answers smaller than 2 pi. All right, on to the next one. This is just a little bit trickier, okay? What I want you to notice is that you do not have a formula for sine at 3x. You have sine at 2x, but you do not have sine at 3x. So we have to get a little bit creative from the beginning. And I am going to say that's 3x, is the same as x plus 2x. Okay? People get tempted to distribute this through, but you cannot do that in trig when you're dealing with summation of angles. So, so you do, instead of distributing, need to use your sum and difference formulas. Okay, so pretend this is your alpha and this is your beta, and you're going to use this little formula right here, which is your sum and difference formula. So I am going to replace this then with sine x, cosine 2x, plus cosine x, sine 2x. Okay, and then of course I have my sine x over here. All right, now we need to get just a little bit even trickier than that. Okay, notice I have these cosine 2x's in here and a sine 2x in here. Okay, those are going to be replaced with their double angle formulas. So now I'm going to use these formulas down here to replace those. Okay, so I'm going to try to bring this down so that you can see. Here's what my sine x is. Okay, plus I'm going to bring this sine x down. This is going to get replaced by one of the double angle formulas. Okay, and actually you have 3 formulas to choose from, and you can play around. Any one of them will work. Play around with the one that you think might work best. I am going to replace that quantity with 2 cosine squared minus 1. I'll bring down my cosine x, and then sine 2x. I only have one choice right here, and that would be 2 sine x cosine x. All right, we have kind of a mess going on here, as you can see. Okay, so now what you need to do is you need to distribute some things. Okay, so I will bring down this sine x, and I will distribute this through. You know what? I'm going to make that a little bit prettier. Sorry. Sine x times 2 cosine squared x should be 2 sine x cosine squared x. Sine x times -1 is negative sine x. Okay. Then when I clean this quantity up, you're not distributing it because there's no addition or subtraction signs in there. So you're just going to multiply that out, but clean it up and make it a little bit prettier. I would have 2 sine x cosine squared x there equals 0. All right, we're getting there, you guys. Okay. So now this and this can cancel. These are like terms. They are both a sine x and a cosine squared x. When I add them together, I have 4 sine x cosine squared x. Okay, so here's what you need to think about. Basically, if sine x was 0, 4 times 0 times, it doesn't matter what cosine squared x would be, as long as sine x is 0, the entire quantity is 0. Okay, so one of my solutions would be if sine was 0, 4 times 0 times anything would still be 0. So I'm going to look for where my sine value or my y value is 0 on the unit circle. Okay, so I'm going to pull that in again. And again, I should have done this earlier, sorry. All right, I want to look for where my sine value or my y value is 0. Okay, all the places on the unit circle, not just the ones in the restricted interval. So you can see that your y is 0 right here at 0 degrees. Your y is also 0 here at pi. Okay, so this happens at 0 and at pi. The same is true here. If cosine squared were 0, then 4 times, I don't care what this is, times 0 would still be 0. Okay, so I'm also going to figure out where cosine squared is 0. If you square root that, square root both sides, the square root of 0 is still 0, and it's actually positive and negative 0. Okay, so now I need to look for where my cosine value is 0, and that happens here. Cosine is your x value at 3 pi over 2, and it also happens here, where your x value or your cosine value is 0. So that happens at pi over 2, and it happens at 3 pi over 2. Okay, and now we're going to do a couple where we actually have some numbers in there. We are going to use some half angle formulas next. Okay, so the first thing I want you to be able to do is find sine at 5 pi over 12. Most people think it's easier if you convert this to radians, so that's what I will do. Remember that to convert to degrees, I'm sorry. To convert something that's in radians 2 degrees, you multiply this by 180 over pi. So this becomes sine, if I cancel the pi's out, 5 times 180 divided by 12 becomes sine at 75 degrees. Okay? And if we think about our unit circle, we do not have 75 degrees on it. Okay, so a couple of days ago, we learned how to find that by finding two angles that either add or subtract to make 75 degrees. And another way you could do it is to use half angle formulas. Okay, so what you do is you kind of double this quantity and cut it in half again. Okay, so if I double 75, I have 150. So this is what I'm going to do. Sine at 75 degrees is the same as sine at 150 divided by 2. Okay? And now you are able to use your half angle formulas, and 150 degrees is a spot that you have on your unit circle. Okay? 150 degrees is right here. It's something that I have. So I am going to use this formula right here. And I want you to notice that if I do this, this 150 degrees is your theta in the formula, okay? So that's what you're going to plug in to the right spot in the formula. All right, so this becomes plus or minus the square root of a 1 plus cosine at 150 degrees over 2. Okay, so now you're going to go to your unit circle. You're going to go to 150 degrees because you have that spot. Cosine is your x value at 150 degrees. So I look here. My x value is negative root 3 over 2. So this is what it looks like. Okay, and these get just a little bit tricky to simplify, but not bad. You do need to break these down a little bit and simplify some things under the radical. Okay, so this becomes positive or negative. You're needing to get common denominators up here on the top. So I'm going to change this 1 into 2 over 2 so that I have common denominators and I can put that into one quantity. So I have 2 minus root 3 over 2 all over 2. Some people think that those 2's will cancel, but I need to remind you that this is really 2 over 1. And so when you flip that double fraction, instead of dividing by 2 over 1, you can multiply by 1 over 2. Okay? So instead of dividing by 2 over 1, multiply by 1 over 2. And then when I do that, I get 2 minus root 3 over 4, which then, of course, you can think of as the square root of 2 minus root 3 all over the square root of 4. And again, this is plus or minus. Okay, so plus or minus 2 minus root 3, and then the square root of 4 is 2. So pull that out of the radical. The radical should no longer be, or that 4 should no, or the 2 should no longer be underneath there. Then your very last decision is to decide whether this is positive or negative, which for some people is the trickiest part. But you go all the way back up to the original angle that I gave you, which was 75 degrees. Okay. So I go to 75 degrees, and I don't have it exactly on my unit circle, but I do know that 75 degrees is somewhere in here in quadrant 1, okay? And up here in the corners of your unit circle, you have lists about which trig functions are positive and negative in those quadrants, okay? So if I know that 75 degrees is somewhere right about there in quadrant 1, and I'm needing to find sine in this case, I'm going to look for whether sine in quadrant 1 is positive or negative. And sine in quadrant 1 is positive, and so I know that my answer is the positive root to this, okay? And only the positive root, not plus or minus. And that's that. Okay, we'll do one more so that we get a little practice with that, and we'll move on. This is tangent at 195 degrees, okay? Again, if you think about your unit circle, you do not have 195 degrees on your unit circle, and so you can't, you have to find a different way to do that, okay? So you are going to, again, use half angle formulas in this case. We could do addition and subtraction formulas, some difference, but we want to practice half angles today. So I'm going to double 195 degrees. So tangent at 195. If I double 195, I get 390. Okay, and it looks like we don't have 390 on our unit circle either, but remember, all the way around is 360, plus 30 degrees more would be 390. So here's 390 and 30 degrees are the same thing, okay, just so you know. Now, when we use these formulas, I'm using the tangent formulas right here, and I want you to notice you have 3 to choose from. You can choose any of the 3 and get the same numerical value. Your answers will probably look really different, but you will have the same numerical value. I personally think if you can choose it, this is the easiest one to choose because if there's radicals in the denominator, they are the easiest to rationalize. So I like to choose this third one, and that's what I'm going to do. Notice that in the formula, I have 390 plugged into that spot, so my theta is 390, okay? So I'm going to use that last formula and do 1 minus cosine at 390 over sine at 390. Okay, we already talked about how 390 was the same spot on the unit circle as 30 degrees. So I go to my unit circle, I find cosine, which is my x value at 30 degrees, and that happens to be root 3 over 2. And then I go to 390, which is the same as 30 degrees. I find my sine value, which is my y value, which in this case is 1/2 at 390 or 30 degrees. Okay, so now the last part is to just simplify this a little bit. Again, you need to get these two as one quantity, so I'm going to change that to 2 over 2 so that I have common denominators. And this becomes 2 minus root 3 over 2 all over 1/2. Okay, and then you can think about, instead of dividing by 1/2, you can multiply by 2 over 1. The 2's cancel, and you get 2 minus root 3. Now, I need to tell you that if you had chosen a different formula, your answer might look very different, but if you plugged it into a calculator and got a decimal value for it, it should be the same as somebody else whose answer looks different, their decimal value. Okay? So that should be that lesson.